Okay. All right. So, so if you actually start writing, creating a new list, right now when you say it's an integer list, now you cannot actually do this. You cannot say lst.add new person. Right now the compiler will actually scream at you and say, hey, you are doing something stupid, right? Or you cannot actually even add 2.5 f, right? Right now it says, hey, I cannot cast this back to an integer, right? Directly. I mean, you can like, I don't know, you can floor it or something so you can or floor it or like sealing it so it can actually be casted to an integer and you can work with it. But in any case, excuse me, you cannot add crazy things in there. However, if let's say you have a person and then you have a class professor, for example, what would happen here is the beautiful thing about generics, it still respects as well the polymorphism, right? So you can have a list of persons, right? And then you can say lst.add a new person, and you can say lst.add new professor, right? And it is legal because both of them are persons, in fact, like according to the rules of polymorphism. So, so this is a very important thing to know. Other examples of strongly like other examples of languages that are not strongly typed, or what they call it loosely typed language, is for example Python and JavaScript. These are the languages which are loosely typed, where you can literally write x equals to a new person, and then down the road somewhere x becomes something else, and the compiler will not scream at you, right? Uh, like treating it as something else, right? So that's the thing. Okay, so this is more or less about generics. You can write your own generic functions, um, which is like a chameleon. It just simply changes according to whatever type you put in. So if you have, for example, a static void add t, which takes, for example, a t, a and a t b, right? Actually, it will return to you a t, okay? When you create a function like this, or a method, I would say, let's say I would like to create a method which adds to a and b, right? So we can say a plus b, right? So return. Now, of course, this is a little bit dangerous because you have to make sure. Yeah, of course, because this is super dangerous, right? You cannot do that. We can say, yeah, I'm gonna overcomplicate it. Nope. Let it be. Let it be. Hmm. Because if I do that, it's gonna be. Okay, let's assume for a second that this is correct. Okay, for a second, because I have to write additional code for this. Let's assume this is correct for a second, and you would like to write an adder that adds two integers, two floats, two persons, whatever, right? And if you say add, right, and because it's a t, if you write 1 and 1, what will happen here is add becomes integer, integer, and integer. If you say add 1.5, comma 1.5, this becomes double, 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 right? And if you actually have add new person and a new person, right? Persons already has been erased, right? So let me just do a quick class. Not these braces, please. this becomes a person, a person, a person. That's the point behind generics, right? Right now you have a generic function or generic method that handles, let's say, addition for any type you have, right? And now, of course, we have to be sure that we can add two objects, but this is right now another thing which is beyond the scope. So this is one of the things which I wanted to show you regarding generics. Okay. So you can write your own generic functions. You can write your own generic classes. By the way, you can put your own generic constraints. So you can say, for example, where t is, for example, integer, for example, right? Or type of, I think, what was it? Where t, for example, is what if we have a list of objects, like bar list of objects. Due to the polymorphism, we can put int float or some other class in our list. Yeah, you see, you start losing the point here when it comes to. I mean, what you are saying is completely valid, but right now the generics point is actually it loses the generic part, like the strongly typed part. How can I put this? The problem is what you are saying is completely valid, but for some things, but not everything, right? You will not do it with an object, let's say. You will do it, for example, with, imagine for a second that you have something like this. I will tell you when is your question is is your pattern is valid when you have something like this. And let's say for the sake of argument that you have something which is called string public string, right? which is a console.writeLine something, right? I don't care what it's gonna print, right? So let's say it's printing this, okay? Oh, sorry. Not a console.writeLine. Return let's say that this is what you would like to return. And then for the sake of argument, you are actually inheriting this. Now when you're going to use this, you're going to use this when you actually start defining something like, let me just stop this for a second. And then you can say, for example, is var lst equals to new list of persons, right? And then you say lst.add new professor. Oops. lst.add new person. And then you have a for each loop, right? For every item in the lst, you say item dot print, right? Now, each one of them inherited already from a person. However, for example, if you have something like this, so for public, so you have, for example, for the student, you have a public and index. Here he's gonna have, so let it be a getter and setter as well. And you have here public and number of subjects, right? Number of subjects teaching. Just for the sake of the argument, right? Now here's where it gets interesting. If you actually press the dot on the item, you will not see this nor that, right? And the problem is you cannot say, for example, var x equals to and then professor of item, right? Because you're gonna get a person at the end, and then you're gonna have an invalid casting exception going on. So when you're going to actually use the polymorphism mechanic or mechanism, I would say, is, you know, like when you have something joined. Okay? All right, good. And you're going to see it actually right now when we expand on interfaces, because I'm going to use interfaces and generics in order to leverage some of this power of polymorphism. Okay. Now, one of the things which I wanted to mention as well are generic constraints. So, so let me push this right here. Hang on, let me find it. So there we go. So these are generic constraints in C#. Feel free to actually have a look at it. So where T is a struct, so you're actually making sure that this is actually a value type, a non-nullable value type. Where T is class, so for example, make sure that it's actually a reference type or a nullable reference type, right? Unmanaged, this is something else which honestly I haven't used because I haven't went that deep with interfacing with other I would say like internal Windows APIs and these things, but it's actually quite useful. And also you can say where T is the base of an interface. So let me push this to the chat. So right now you have it. You have that link. Have a look at it. You have already a lot of examples on the topic. Okay, and I think it would be useful for you to have a look at it, right? All right, so we're gonna actually have a look at it actually up next. We're gonna actually touch upon it hopefully in the next example. Before actually I just carry on, do you have any sorts of questions? Is everything is clear? Well, folks, by the way, this is not appearing in the recording if you are worried a little bit that you will appear there. Okay, I will take this as a no. Nobody has any problems. Still clear so far. Okay. Okay. So let's talk about the let's talk about interfaces. Now, interfaces are contracts, right? Upon which once you say I'm going to implement that contract, you implement all the clauses within that contract, right? So it is very, 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 very important that you understand this, because if you forget the idea that it is a contract, you will start having huge problems in your software, right? What the heck am I talking about? Today I was not like today. In the past, this week, I mean, I was talking to students like to see. I want to train their muscles a little bit. So I told them, okay, Dennis actually have shown you in classes, and you have it already recorded on YouTube, how to create, how to use or leverage interfaces with dependency injection. Hopefully, you're going to see it in the future. How you're going to leverage interfaces in order for you, for example, to create a bunch of loggers. So you can have a logger which logs to a file, or a logger that logs to a database, or maybe log to a screen, right? And if you would like to log to multiple things at the same time with generically, right now all what you need to do is just simply have an interface type that just simply starts like, you know, giving you this functionality, and you are just simply calling the methods within these interfaces that will invoke the stuff which has already been implemented in classes, and then you will have your like kind of nice abstracted layer where you don't care about the implementation anymore. You just simply care about somebody implemented the contract. You will be logged. I will log that object, or this will actually appear in a database or a file or a screen if the contract has been implemented appropriately. So for example, if you have a, which Dennis already showed in the materials, if you have, for example, you have, for example, some sort of operations are happening, like adding a student, for example, to the database, and then you say, I would like to log that, and the business requirement is saying that, hey, we're going to log today to a file. You just implement the interface for iLogger, and then you do the logging part. And then the next morning, they say, hey, we're going to log it right now to a file. So one is the database, and then you say, I would like to log it to a file. And then you will say, okay, right now this is a new requirement. We were logging every day on the database. All what you need to do is just simply like, create another type, which implements the same interface, right? Which says logging to a file, and then you start logging to a file, right? So that's one way of actually leveraging interfaces. In some cases, at the future, you will end up with, when projects get a little bit larger, and well, when they get larger and larger, you will start to have to write some business rules. And the business rules in an application is something that manages the objects within the lifetime of the application, where it doesn't yet hit the database, but you have to manage it in the memory and manage it how it actually goes like, on the goes around in the application life cycle, and shows up onto your screen before it hits the database. This is like when the applications really get large, and which you're gonna see that in the future for sure. God willing, when you graduate and you work at companies, etc. I will show you some sort of a flavor of this in a game kind of style, so you can see a little bit of a difference. So you have the one which you're going to see a lot, like the database loggers, and that example, you're going to see it in, you're going to see it with, you already have it in the materials, like you saw it already with Dennis. I will show you the other flavor. So you have both of the flavors in, and then you just simply can play with it. So let us do it. Now, one thing I just wanted to mention before I actually move on, I will have to show you the for each loop, the details about it, and I would like to show you how to document your source code, how to write proper documentation, which you could have in your application, right? So this is also important. I would like to have, I want you to understand of its existence, and I want you to use it. So I'm gonna actually, hopefully I will remember this. Now, I usually like in the class, I gave an exercise. I told students, hey, can you write me a program that does handle, for example, tic-tac-toe, right? Or cross, knots and crosses, right? If you are living in Britain. And sure, I was giving them the class and the exercise, and they were like starting to form up some patterns. Interesting patterns, I have to say. And I will actually, like, when we were actually like working on it, we were discussing things, right? And things were going back and forth. And then I like let's say I was just like saying, okay, I'm going to use your idea, use the other person's idea, use another third person's idea, and we mash it all up in a nice way, where we produce the following code, which you're going to see. Now, if you are producing a tic-tac-toe is a board. We can consider it as a board game, right? It's like a flat game. However, I would like to make it a little bit more than that. So I would like it to make it a little bit more generic. So I can, for example, if tomorrow morning, for example, I was working on a tic-tac-toe, it has been released, right? And the next morning, the guy said, "Hey, we have some additional money, and right now people love the tic-tac-toe, and they would like to see a game of checkers." So you actually like sit down instead of right now you what if you actually didn't write your software nicely, what would you do is write the whole stack from start to finish, right? You're gonna have to write like you have to write the board, you have to write like all sorts of stuff that checks it makes what makes checkers is. And then after you release checkers and everything, the guy comes back at you again and he says, "Hey, we would like to have chess right now, okay? Or we would like to have a game of Go." And right now your code will start to be unmanageable, right? Because you are right now like starting to repeat the code over and over and over again. Now, of course, people will say, "Okay, right now time's to generalize the code," right? So at the end of the day, when you look at tic-tac-toe and you look at chess and you look at game of Go and you look at the checkers game, all of them are just a simple board games of some sort, right? So so for example, tic-tac-toe is a 3x3 game. You can go bananas with it and have it like more than 3x3, but it's by the standard is 3x3. You can if you look at the game of chess, as far as I remember, the board is 8x8. So it's actually a bunch of cells, if you will. Game of Go, I forgot what was the number, 20 something by 20 something, or I cannot remember exactly. The shogi, for example, or shogi, right? We have it. I don't know how many of the cells also there. So right now you understand the requirement, right? You have something that it has to be dynamic, yet it has to represent multiple games, isn't it? So what would you do in this case? Now I will actually propose something. I'm gonna write it halfway production ready, let's say, right? But just for you to see the flavor of it, like to get the feeling for it. Because there is a lot more to add to make this much better, but I will actually keep it simple because again we are just looking at this for the first time. So I'm gonna have I have to create a class called board. So public class board, right? Now the board consists of cells, right? Cells of stuff that you're gonna actually just like mark them or insert them in. Now, there are many ways of fixing this right, but for the time being, I'll just keep it in this format so you can like relate to it a little bit. So let's say you are having, so before I actually get into that, if you would like to position something on the board, like position a figure on a board, then it has to have a location, right? And the board has to have a size. So at the end of the day, what I could do is simply say, okay, a certain board has to have a, let's say, a 2x2 array. For now, I'm going to call it 2x2. You can actually make it a single dimensional array, and you do the math, right? For index math, where you actually like jump correctly between cells, so you can make this even more efficient than bidirectional. Then how do you call this? There are square array, right? Or rectangular array, if you will. So we need actually something to represent the position of figures on the board. So I'm going to have actually a public class, and I will call it right now position. I called it in my class as a vector because of game dev and stuff, but I'll call it here a position. And I will assume that you are working with integer positions, like the cells has to be an integer, okay? And right now, what we need to do is define what the figure is going to be, right? So the figure, which you're going to position on the board, can be another class, right? And not only that, it can be in fact an abstract class, but we're going to see in a second how can this be. So public position, position, and then I'll call this. Yeah, this is why I actually escaped the word position. Yeah. Okay, fine. So I'm going to call this vector. I'm going to call this position because I would like to have this position, capital P. Okay. And when you actually go ahead here, you can say, for example, I have a public public figure, and then it's going to be two-dimensional array of figures. And I'll call it, I usually call it in my classes the board, right? Because I don't have any better creative name for it, right? And not only that, I will utilize even that vector again. I'm going to give it a board size. So far, it is simple, right? There's nothing fancy about it. You have a board of and that board has a bunch of figures, right? And everything. Now, what else would you like to do? Would you like to actually one of the things which you would like to do is create a board with a specific size. So you say, sorry about that. You have it takes you know what? It takes a vector as size, right? And you say, hang on, according to the standard, I think it should be s, smaller s, size equal to, yeah, the board size equal to the size, okay? And of course, you need to instantiate this. You need to create a new out of this. So you say the board. You can say this dot the board, or you can actually just simply remove it. Equals to new figure, and then you pass in here size of x and size of y. Right? Also, what you could do actually not even needed. There you go. This is even better. Because you don't want the board size suddenly to change, right? So if you're actually making a game and then suddenly somewhere in the middle of the game, you just simply say change board size. Usually to my knowledge, tic-tac-toe, Connect Four, the shogi and chess and other board games, they usually don't change size all of a sudden while playing. Even though that would be an interesting mechanic, like, hey, I have additional room to move in. But I would think it would drive the chess masters crazy if the board was actually dynamically sized during the gameplay. Unexpectedly, like, okay, right now we're not 8 by 8. Today we are 9 by 5. You know, just live with it. So, so this is actually ensures me at least that nobody will do that. Okay. Now, let's assume, and this is wrong, what I'm about to pull out right now, but let's assume that the board has the job for drawing itself. Like, how can I render the stuff on the screen? This is not its place. This is totally wrong, but I'm trying to compress the code just to show you the point here. Okay, so if I have a public void draw board, right? And right now you would like to draw the board. Here comes the interfaces bit. Now, if you actually, like today you are writing a console application, but if we would like to take this code and push it to Windows application, that draw board will fail. And then you think to yourself, fine, it's okay, I'm going to write another function or another method that will render to a Windows Forms. And then later on, there will be some money on the table, and then they'll say, hey, here's the money. Please make it work on mobile. Please make it work in 3D, right? Or something along these lines. And right now, your code will start to get messier and messier, right? So how actually to resolve that? If you remember the examples from Dennis is like the logger interface. This is exactly the same pattern which I'm going to actually use here. So I will leave this empty for now. And again, please remember that the drawing of the board is not the job of the board, but I'm just putting it here just to give you an example, nothing more. Also, one more thing. A board itself is in fact, right now, as of this, like as we talk right now, it is not generic, right? It's not strongly typed. Right now, that board can hold any kind of figure, right? So if you have a game of chess or a board of chess, you cannot differentiate it completely. I mean, you can differentiate it, of course, when you create an object out of it, but it is not so efficient to insert, for example, chess figure inside a tic-tac-toe, for example, right? So how can I ensure that this board is strongly typed, right? This is also an interesting bit. So in order to ensure that, I have to make sure that the figure is of T, right? Not only that, I would like that the figure can say how I'm going to be drawn. So I'm going to say, it's going to be an abstract class. This is right now, you're going to see the difference between abstract classes and interfaces. And I'm going to have actually a public abstract, and then I have iDrawable. And iDrawable is going to be an interface. Whoever implements that interface can actually be drawn on the screen. I'll just simply call it graphic, and that's it, right? Now, iDrawable doesn't exist, so I'm going to make up one. So I'm going to have a public iDrawable, public interface, iDrawable. And then I have a method within the iDrawable, which says, which is called render, right? So, so this is going to be a render, basically speaking. This is a very small contract which says just render. Sorry, no, hang on a sec. Now, because we are generics, by the way, I forgot to say that this render has to return whatever is going to actually draw. So I'm just going to have the T here and T there. Now, here's the interesting bit. If you are actually going to be drawing graphics, then this T becomes graphics, this T becomes graphics, you're going to return to me some pixels, for example. If you're going to be running on console, this is going to be a string, and this is going to be a string, and it should work out. If you remember from creating a small list, so if you say lst var lst equals the new list of integers, right? If you say lst.add, right now you have integers, right? So that's super important bit. Okay, so I will have it here as well. So a figure of T, iDrawable of T implements, you know, like, so a figure will be rendered if actually the figure implements the iDrawable of T, right? And you have to say how we are actually rendering this thing. So, for example, yeah, right now, of course, we have a problem because right now figure became a strongly typed, it became actually a generic type. So right now, the board has to be generic as well. So right now this became of t, this became of t, this became of t, right? Now here's the interesting bit. If you would like, for example, to public void add figure for a second here, and you say, for example, and it's going to be actually a figure of t. So we have a figure of t figure, and you have, I think I should have had this, was it? Hang on, let's see. Yeah, it's fine. Because this is implicit typing, this is explicit typing as far as I remember. I think you can do that too. But right now the compiler says, hey, you don't need it anymore. So it's just, yeah, it's just unnecessary right now. So you have a figure of t, and you have, for example, the vector, not vector. Oh yeah, I called it vector, yeah. So vector, oh boy, position. And then you say, for example, board, the board of position of x and position of y, right, is going to equal to the figure which you passed, right? So let's say for now that is going to work so. Now when you're actually going to add a figure, it will actually just, you know, it will flow through the, if you have actually a board of chess, this becomes a chess, this becomes chess, this becomes chess, right? And the figure which you're going to have is chess. If you are making a tic-tac-toe, it will work the same way, right? So that's that's the premise here, okay? So right now you'll say, okay, fine, this is all beautiful, but how can I leverage this, right? How can I use this? Now here comes the interesting part. How can we draw the board, right? So for a second, let's imagine that you would like to create a pawn, let's say, right? So if you would like to create a pawn in chess, for instance, or a knight or a bishop, you will create a public class pawn for it now, and you will say that this actually inherits from a figure, and that figure is going to be having a string representation, right? Now again, I'm well aware that right now the representation of a figure is coupled with the actual definition of pawn, right? But again, this is gonna be fixed even a bit later. Now here's the interesting bit. Because I have an abstract class, and I said there's an abstract method, whoever inherits from figure is forced to implement the abstract class. And as I've already said before, the job of an abstract class is programmer A, half of the implementation. Programmer B comes in and continues the implementation. So I say, okay, here's what I think you have to have, and this has to be there, and it's going to be always there. Figure's position, figure value, and so on and so forth. However, I don't know how the figure will look like. So I will let whoever inherits from that figure to define how it will look like. So you say, okay, I'm going to mark that method as an abstract. And right now, as you can see here, it says, hey, it does not implement that abstract method, right? So if I hit Alt-Enter and say implement abstract class, right now that graphic has to return to me a type that actually implements the iDrawable interface of a string, right? Because everything is right now strongly typed, right? Yeah, that T started to take shape right now, okay? However, I don't know, I cannot return, you see, this is the interesting part. You cannot say return a string, right? This won't work because string doesn't implement iDrawable interface. And that's why you're going to have a public class pawn renderer, which actually implements the iDrawable interface of a string. And then if you hit Alt-Enter, you actually here implement it. So you can, for example, return the pawn. This is my render for the pawn. I'm fine with it. And right now, you're gonna just simply say return new pawn render. Now let me see. Before I carry on, did I lose anybody? I know it's a little bit abstract, but I would like to see. Do you have any questions so far? Like, are you okay, guys? Hello? Did you fall off your chairs again? Okay. You guys can hear me, right? You still can hear me? Hello? Oh boy. Oh, come on. Don't be so late with the response, please. It's stupid right now if you don't respond that fast, because honestly I thought that I was talking to myself all the time right now. Okay. At least you can hear me. Just if you cannot see things right now, just please feel free to like rewatch that video anyway, it's recorded. Just rewatch it, and hopefully if you have any questions, feel free to hit me up on the chat or emails, right? Now here's the interesting part. What is the gain here, right? What is exactly the gain? If I actually would like to draw the board, okay, if I'm about to draw the board, this is where this becomes interesting. So if I have a for loop for I equals length a, okay, so I'm going to have say board size x, and then you have another for loop of j, and then board size dot y, right? Now what you can do, and I know that this is wrong, but I'm just gonna put it there so you can like um, so you can see the effect. Okay, I will just simply say console.writeLine the board of I and j, and because every figure, right, every figure has to have a graphic implementation which returns the iDrawable interface, which has the render method. I can actually invoke that, so I can say dot graphic, and it's a method, right? Dot render. That's it. Done. Right now you can actually, because I mean I have this console.writeLine, but it's totally fine for now. Right now, whoever would like to change this, they can change this to a graphics. They can change this to graphics, and it will work. And this is agnostic to it. It doesn't know. This board doesn't care about your, actually, okay. Now that board doesn't literally care about your output, basically speaking. It just says, hey, I'm gonna just draw the thing. All right. So that's the actually right now it's correct. Right now it will just simply render the stuff correctly. However, you have to write the implementation detail, how this will be rendered right there. Okay, so here you actually should have some sort of a console. So probably this has to be void at the end. I think, yeah, this has to be void for now. I'm actually like trying to make something up here. So right now I've offloaded the implementation detail to the render, and it will work right now. So right now this will be called, and when this is called, it will call this. You see the compiler already, or the ID already highlighted it for you, so it will go right there and just simply renders it. If you woke up in the next morning and somebody told you, hey, we're going to have a 3D, fine, you just simply like, make this, create a new a pawn 3D. Inherits from figure of, I don't know, 3D, right? Because we don't have 3D right now. And then, okay, you cannot have numbers at the beginning of the name of a thing, so we can have 3D, right? So I'm just making up stuff right now. And then you're gonna have something like iDrawable of 3D, right? So that's the point here, right? And then you can push that into the pipeline, right? You can right now add to the board actual, like when you create a board with a 3D board, right? You're gonna have all these stuff confirming, all this stuff confirming correctly. So that's the point behind generics, interfaces, and using them together to leverage that power so you can abstract your class implementation to a point that you make it agnostic to whatever it has to do, right? Like to agnostic, for example, in this case, to an output on the screen. In Dennis's case, when he showed you, it is agnostic to where it's gonna write data. It's gonna have write data to a database, to a file, to the cloud. It doesn't really care. It just there has to be a contract that has to be implemented in order for you to be able to be written. If you don't implement that contract, you're not gonna be written. So that's the thing. Now, now I'm gonna actually, because this is 9915, I'm gonna give you a short break for 10 minutes, and then we will get back. I need to show you for each. I need to show you how to document your code, and then we will call it a day, all right? All good? Peeps? Hello? Okay. See you after the break then. All right. You can hear me? You're still there? Yeah, hello? I think 10 minutes has passed. Okay. Okay, so let's finish this off with the for each loops and what was called and documenting your code. So um, what you see here is an example. What you have seen right now is an example of using interfaces and polymorphism, um, like in code, and I think it's not a bad example. So I will keep it here. Again, please remember that this can be refined even further. This is not like a final version, but I just wanted to show you how these things can be leveraged, right? How can you like pull this off nicely? Okay, so a for each loop is in fact the same, um, has almost exactly the same idea. If you would like to do a for each loop over a collection or over an array of some sort, a list, that list or that collection has to implement the IEnumerable interface, and of course, and as well as the IEnumerator. But for now, it's uh, let's say that it's that collection has to implement the IEnumerable interface, right? If it implements the IEnumerable and IEnumerator, then you can actually do a for each loop over that collection. Here's the interesting bit, though. There is a difference between an enumerator and an iterator. Okay, an enumerator is a way of like traversing or enumerating over, like you go one by one over items and you read only from there. Iterators are a way of reading, actually, you can actually read and write or change the objects in a sequence, okay? Or in an array, for example, right? So that's the key distinction here, okay? Now, why I'm talking about this? Because if you have a var lst equals new list of ints, so you have a new list of ints, and you say lst.add one. Oops, hang on. Actually add it like this. If you like, if you have a bunch of numbers you would like to add, just simply put it in the constructor. It will work. Okay. So right now you have a list of integers from 1 to 9. Fine for the OCD of you. Right. And you would like to for loop over this. So what you usually did was like in C++, you had this a for loop where you can just simply say lst of I, lst.count, right? And then you were like saying, for example, console.writeLine, lst of I. And I think you had in C++, you had iterators, right? You were actually playing with iterators with Dennis in the last semesters, right? Or in the previous semester, first or second, okay? And what C# gives you is a way to enumerate over a collection. And what you do is you write a for each loop. You say for every item in the collection. So for each item, yeah, in LST, right? You say console.writeLine LST. Now, if you remember from the first lesson when we were talking about lowering, right? When your code gets lowered, your code is actually being rewritten in a different way. So if you look at the for each loop, the for each loop is in fact like a, I wouldn't say it's a syntactical sugar or anything, but I want to say is it's a way, it's a nice way to rewrite this. So var enumerator equals to lst.get enumerator, and then you say while enumerator dot move next, right? As long as you can move next, and it is in fact a Boolean, you have enumerator current, sorry, var item equals to that. This is it. This, hang on. This unpacks to this, okay? This is what your for each loop actually is, okay? Now, how on earth did I know about these? It's because if you look at the list source code, F12, it implements the IEnumerable interface, the generic version, the non-generic version, right? And if you look deep down, it has a struct within it, which implements the IEnumerator interface. Excuse me. And you have there current, and current is get only, right? It's a private set, but let's say but in general, I mean, okay, it's not a private set, but in general, it's a get only, right? That's why if you try to do something like this, dot current equals to 10, it will scream at you, right? And this is why if you go here as well, it has to scream at you, right? Here's the interesting part though. You could argue and you say I have a new person, right? And you can tell me, hey, I could do this, right? So this is illegal. So illegal. And oops. Oh, hang on. And this is illegal as well, right? So this is illegal, this is illegal. And then you can say, for example, hey, I could do a var p lst, which is a person's list, equals to new list of persons, right? And we will assume that you're going to create a bunch of persons, right? So that's that. And then later on, so you do your adding. So you add stuff. And then later on, right here, you can say, for example, for each var item in plist, right? You say item. You cannot say, for example, items equals to null. You cannot do that, right? This is still illegal, right? So this is illegal. We agreed on that. However, you can do this. And this is very interesting. Right now, what you can understand from this is you cannot change the object reference itself. You can only read it. But you can change its properties, okay? So the object reference you cannot touch. You cannot modify. But you can only modify its properties like this, okay? So please do not mistakenly think that you have actually went around this illegality stuff, right? You didn't go around it. You simply just modified the properties of the object, but not the reference, but not the object itself, right? You didn't, for example, that item didn't become another item. It cannot be null. It cannot be a new item. So if you So if you say item equals to a new person right now, that guy becomes completely different person. This is again illegal. You cannot do that, right? This is as well illegal. Okay? So for each loops are enumerators. So you can actually enumerate over objects using for each loop if they implement the IEnumerable interface and IEnumerator interface. Implement both of these interfaces at any class you have, and you can actually do a for each loop over it. Okay, so that's the thing here. Okay, I think it, but you see, here's the thing. Iterators in C++, you can actually change things, right? With the objects, isn't it? You can, this is C++, this is legal, right? And because this is legal, this is an iterator. It is similar to the iterators in C++. However, if you are in C#, right here in this case, you are doing enumeration. And enumeration, you cannot actually modify stuff. You can only read stuff. So it is exactly like the vector iterator in C++, just it is read only, not read and write. So that's the base case here. Okay. All right. So that covers that part. Let's talk about documenting your code, because I think it's important for you to be able to leverage that power. Actually, what I would like you to do as an exercise, I'm not forcing you or anything, so there are no homeworks or something like that. This is just for you. Feel free to email me your solution. I'm actually going to be quite curious to see it. Go ahead and try to implement the heap and make it generic, right? Just as an exercise, just see how you can actually handle like all these stuff. Handle the operations, try to add to a heap, remove from the heap, right? So and do all these stuff. If you implement a generic heap doesn't exist in C#. I mean, in the system, the collections of generic namespace, maybe you can find it in a library or in another buried namespace. But I think it would be a good idea that, or a good exercise that you can actually do that. But so let me show you how to document your code in a minute here. So if you would like to document your code, there are several ways of doing this. So let's say somebody like, because I mean, if you have a short-term memory like mine, you really need to like leave comments around so you can understand why you did some certain things, because usually people get so involved like with designing stuff, making the code a little bit more reliable and so on and so forth, that you sometimes forget certain interesting abstractions you made for specific reasons. So what you usually do is to start document your code. And usually people like write comments, but in C#, the IDE gave us a very interesting way of commenting on things. So if you put 3 slashes, like 1, 2, 3, you get immediately a summary, right? You get a summary block, the IDE generates it for you. All right, and then here you can just simply say returns I drawable of T. Oh, you see immediately it actually gave it to me, right? I drawable of T object, let's say, right? And here's the interesting part. If I actually written I drawable of T, so let me see here. I think it should somewhere. Yeah, see, it says I drawable of T object, because right now our board is in fact so generic that it actually doesn't say exactly. But when you are actually writing a new board, this will transform. This will become an integer or something like that in the documentation. So that's that. What I can do, in fact, is try to see if if it is illegal to do this. Yeah, it is illegal. Right now I lost the documentation. So let me undo this for a second. And yeah, right now it actually appears again. So this is that. And you can say this is actually returns. So what does it return? It returns actually a type param ref of t. So right now you can actually say it returns I drawable of that. So there you go, returns t, right? So that's that. Now this is one part of the documentation. Another part is, for example, if you have a method that throws an exception. So for example, let's say that this throw new exception, okay? When you throw an exception that this thing is null or something like that, let's say that it can throw an exception. So if I actually put this summary, I could say, for example, renders a pawn, for example, right? However, later on, I could say exception, and it asks cref. Cref is asking me what kind of exception can be there. So I can write now control space, and it depends what can you do. You can, for example, index out of range exception or something like that. For example, I'm just making up the name. I mean, the exception exists. So for example, if you are adding to an array or removing from an array, and you shouldn't actually do that, it should actually throw an exception. It throws an exception in the documentation. And if it has to return something, you can just simply cite write returns. Returns. But because there's no returning, that's why it's not helping me. Okay, so let me take this out. And right now, if you look at the render part, yeah, it has to be, let me just push it right there, because we can see it on the I drawable bit. So let me have this exception. I will, again, index out of range exception. Okay, so for the time being, right? If I look at this, you see, it gives an exception index out of range. Now, if you are actually a developer who looks at the methods which you are calling, you will say, okay, I have to handle that exception because it's going to be thrown out to me. So I'm going to surround this with a try-catch block, right? So that's that. So this is in a summary, like in a short way. I showed you all the possible flavors of how to create a documentation. This is the same thing as when you have a list and you say, for example, lst.add. You see this? Now, if you, for example, add x, add to 1, whatever, and if you look here, yeah, okay, it doesn't say here a list of t. You can see that it's an integer, but it doesn't say here a list of integer. However, if you document your code in that way, it will in fact show you that this can be an integer right here. Okay, so that's the thing. Okay. I advise you to document your code whenever you can, so you leave yourself some sort of a reference, right? So, do you have any questions regarding the documentation bit? Let me stop the recording as well. Stop.